Hello all, good day. Today we are going to look at how a customer cloud journey looks like and what are the options available for this cloud journey. So normally when a customer starts, they have multiple options available to start with from an on-premises infrastructure. They can go for infrastructure as a service or containers or PaaS or SaaS applications. It doesn't really depend on what we have in the cloud, but the approach the customer chooses. The simplest option is rehosting one. So it's also referred as lift and shift migration. In essence, the application is moved into the infrastructure as a service environment of a cloud provider while avoiding as many modifications to the system as possible. In this case, you would not be taking the advantages of cloud technology such as auto scaling and other services. So typically when will we consider for rehosting? So first scenario is like this will be ideal when our goal is to improve the operational efficiency and free up the data center space. So the typical case is that when there is a data center shutdown planned and we want to move the apps out of the data center, this is one of the scenarios which they go for rehosting. And second is like so there needs to be maintenance of the apps which needs to be done, for which that they don't want to spend additional capital expenses on the hardware. That's second one. And third scenario might be that customers might be running the compute intensive applications that are typically parallelized, but they don't require like HPC scenarios. I mean high performance computing using inter-process communication. So if they don't really need the scenarios, it will be one of the use cases for lift and shift. And so basically what are the benefits which you are getting from this lift and shift scenarios? So normally when customers migrate to IaaS, so there is a survey conducted and it was around like 400% return on investment available over a period of 5 to 10 years. And other benefit is that customers don't really need to manage the data centers. And third one is like, so they can easily now scale the infrastructure as and when required. And basically like when you look at lift and shift, there are like virtual machines and virtual machine scale sets. These are the two options which are available for lift and shift scenarios. The second approach is called refactor. So normally refactor means like an application will normally involve some changes either in design or the way it's deployed, but there won't be too much changes in the application code. So in essence, like it takes the advantages of infrastructure as a service partially, and some platform as a service capabilities as well. uh, Normal scenarios are like they don't want to change the application, but they can repack the application into either containers, or if there are ready-made platform as a service available, they can just replace those with those ready-made services. And if there are custom code, they will pack that in a container and they can run as it is on the cloud. So the typical advantages are like normally it's cost efficient, secure, and there may be legacy apps which they don't really need to change, but they can run in the same way on the cloud in containers. So here, like since they are splitting into multiple modules, the advantage here is that like they can effectively use continuous DevOps practices, and they can innovate continuously. And again, like auto scaling is one of the benefit, and obviously portability is one of the biggest advantages as well. And normally the technologies used here are like either containers or the container orchestrators, either it be Docker Swarm or DCOS, Mesosphere, Kubernetes, etc. So these are the options which are available for refactoring. And third one is the re-architect space. So normally re-architect means that there will be subsequent changes in the application, but it takes advantage of the cloud technologies such as auto scaling and dynamic reconfiguration, etc. So there will be like considerable changes in the application and significant time to implement as well. But the advantages is that you can call it as cloud native, and you will be getting all the features available in the cloud. So typically, when do we need to consider this approach? When let's say for example we are running a legacy application for a long time and we need a major revision to the application uh, to improve the performance, or let's say for example we are adding a new feature and the old application don't scale well, then we might entirely design the architecture from scratch, either into a pure microservices architecture or fully platform based architecture. So the advantages here is like, so we can use readily available cloud native services as well, which normally reduce the volume of the code needed to express a capability or a functionality. And next thing is obviously the agility and the scale. The technologies normally used in rebuild is either platform as a service like Azure App Services, or serverless things like Azure Functions or Logic Apps, or microservices solutions like Service Fabric, etc. And finally, like the final option is replacing the application, which is normally like using a ready-made SaaS application in place of in-house built application. So this is the final state of the cloud journey. So this is the complete landscape end to end, how an on-premises applications can be upgraded and finally reached a cloud native state. Thank you very much for listening in. Goodbye.